Alright, at the top of this page I put some little symbols that will help us remember some things. These two are the less than and less than or equal to signs. If you have just the plain one, you'll graph an open circle. And if you have the one with the equal sign underneath it, you'll graph a dot. And then these ones are the greater ones. That one would be an open circle, and that one with the equal sign would be the filled in circle. So first, the definition of a piecewise function is just a function that's made up of different pieces. So instead of just one line that you graph, you'll graph two or more different functions. A step function is a particular kind of piecewise function, and it just looks like steps, like if you look at that movie theater graph right there, or it might look like that. And it's where the piecewise function is constant at each interval of its domain. It just means that it's flat. You can tell if a piecewise function is constant because there will be just plain numbers instead of equations right there. See how we have plain numbers right there? This one's a step function. If we had like 5x plus 2, that'd be a regular piecewise function. So let's look at how much it costs to go see a movie. Since you guys are teenagers and you're older than about 15, if you wanted to go see a movie according to this graph, you would be in this price range up here, which is about $9. If little Lyndon wanted to go see a movie, she's over here, she would pay $5 to go see a movie. If my 98-year-old grandpa wanted to go see a movie, he would pay $6.50. He'd be way over here. So we have step functions in case we have, different categories that we need to be using. So let's real quick summarize that in the table. Basically, if you're between the ages of 0 and this is cut off at 13. If you're between 0 and 13, you pay $5. This up here is on the 13, and it goes up to 55, because straight down right there is 55. So if you're between 13 and 55, you're going to pay $9. And if you're 55 or older, so 55 plus, you'd pay $6.50. Now you might be wondering, what if you're exactly 13? How are you about to pay $13 or $5 for being 13 in this category, or are you going to pay $9 because you're 13 there? Well, that's where the piecewise function helps us use those less than and less than or equal to symbols to help out. So the first thing we're going to put down for our 3 different pieces is that the first price of a ticket is $5. That's if you are between 0 and 13. See that open circle right there? By that 13? We have the strictly less than sign in front of it. When we write compound inequalities, as long as your numbers go from low to high, your signs will always point to the left like that. So the first one's done. The next ticket price was $9. And that was if x was between 13 and 55. Let's look at those endpoints. See right here how there's a closed dot on the 13? That means we're going to use the less than or equal to symbol. And then let's look at the 55. That was an open circle, so we'll put the one without the equal sign. Last, we have it cost $6.50 if you were greater than or equal to 55. And that makes sense because there was the closed circle on that one. To evaluate piecewise functions, we just have to plug in the numbers for x that they're asking us, and we just figure out where does the x value fit. So let's go over here to 2a, and we're going to plug in -2. So f of -2, and now we just have to ask ourselves, does -2 fit right there? Is -2 less than or equal to 0? Yeah, it is. So our answer here is -5. Now let's try plugging in the 5. So we'll write f of 5. That means we're plugging in 5 for x, and we just have to see, where does the 5 fit? Is 5 less than or equal to 0? No. Is 5 in between 0 and 3? No. Is 5 greater than 3? Yeah. So our answer here is 12. Let's do a few more, even though they're not examples. Let's say we wanted to find a number to plug in so that our answer was 4. What could we plug in? Well, we would need to plug in a number that fit for that x, which would be between 0 and 3. So maybe 1. Let's try another one. How about f of 7? Well, where does 7 fit? Is it less than 0? No. Is it between 0 and 3? No. Is it greater than 3? Yep. So the answer would be 12. Let's pick a number so our answer is -5. So what could we plug in so the answer is -5? Well, we would just have to pick a number that's less than or equal to 0. How about 0? So there's a few more examples for you. On the next one, we're going to do the same thing. We're going to plug in -2 and 5. So let's go ahead and do that. This function is called g, so we'll have g of -2. And we just have to see, where does x fit? Is -2 less than 5? Yep. So we use that, 3x plus 4. And now we just take that -2 and plug it in for x. So we write 3 times -2 plus 4. And if you calculate that out, you get -2. Let's try it for the 5. G of 5. So first we have to ask ourselves, where does the 5 fit? Is 5 less than 5? No. Is 5 greater than or equal to 5? Yes. So we're going to use that function, x squared minus 3. So now what do? We take that 5, plug it in there for the x. So it's 5 squared minus 3. 25 minus 3 is 22. So if it helps you that first column is your answer, and then the second column is where it fits, that might help you. Alright, now for graphing them. 3a, see how these are all plain numbers? They're just constants. This one's going to be a step function. So the first thing I'm going to do is go to -4 and draw a line through -4, just like that. Now if you're using a pen, you might want to switch to pencil because I'm going to erase part of that line. So that's -4, but we need to cut it off so that it's only on the part of the graph that's less than -2. So here's -2. I'm going to draw this kind of red dotted line right here. And we only need the blue line that's less than that red one. We only need the part on the left, which means we're going to get rid of all of this over here. Now we just put the endpoint. See how that's just a less than sign? We put an open circle right there, and then we're done. We don't need that red arrow, that's not part of the graph. But we should put a blue arrow at the end of that. So the first one's done. Now we'll graph the second part. I'll graph that one in black. So I'm going to go up to 3. Alright, there's 3. But we only need this graph to be in between -2 and 4. So I already have that dashed line where -2 is. I'm going to go over to 4. And we only need that black line to be in between those two red lines. So I'm going to erase that part and erase that part. And now I figure out what the endpoints should be. So see how that has the equal sign by the -2? That one will be a closed circle, And see how that one doesn't have the equal sign? That one will be an open circle. Alright, last one. We need to graph that 2. So y is up 2, right there. But this time it needs to be just on the part of the graph that's greater than or equal to 4. So we only need the part of the graph that is from this 4 that way. So we are going to get rid of everything that comes before it. And then we decide what kind of endpoint. Since that's an equal sign right there, we put a closed circle. And we'll put an arrow on the end of it. So that's how you graph a step function. Notice that we have a closed circle and an open circle, and a closed circle and an open circle on top of each other. It wouldn't make sense for us to have 2 closed circles because you can't have the function equaling 2 different values at the same time. So we'll leave that as an open circle, and that takes care of that graph. The next graph is not a step function. We just have to graph each of these lines. So we need to start at our y-intercept, which is up 2. So I'm going to go up 2 on the graph. Then we need to count the slope, 2 over 1, so up 2 over 1, up 2 over 1, up 2 over 1, and there's the line. Now get your eraser out because we only want this part of the graph to show when it's less than 1. So here's 1 right here. So we only need the part of the blue line that's to the left of that red line. So we're going to erase everything on that side. And we need to figure out what kind of an endpoint. See how that's just less than? We'll put an open circle right there. Now let's graph the other part. We need to start at that y-intercept, which is -2. We need to go up 1 over 2, the rise over the run. So up 1 over 2, up 1 over 2. There's that line. And now we need to figure out which part we erase. This one is only greater than 1. So we need to go to where the red line is and erase all of the part of the line that's to the left of it. We just need the part that's greater than. And now we decide what endpoint. Since this is an equal sign, we will put a closed circle right on that line. Now we're done. Good luck on your homework.